So the next problem we are going to solve the Mastercam lathe operation. So this is the job, finished job, that is top view of the job. So again, in this lathe operation, we perform the whole geometry or draw the whole geometry in negative z direction. So we start from this point. So we start from this point. So this is 8 of direction, and again we draw only half part because the part is symmetric about this x-axis. Okay, so this is 8, this is 25. Again, suppose in this the drilling, this is drill portion, and if drill size is not given, so consider as per your consideration. So suppose we consider 512 is we have to drill up to the length minus 15, that is 15. So perform the same. First draw the geometry over the Mastercam. So just start. This is a Mastercam window. Okay, and again to visualize the axis we have to press F9 on a keyboard key. Okay, so function key 9. So start, create line, end point. Okay, so start from this up to this. The distance is 8. Enter. Okay, from this to this the distance is 25. Enter. Then again check the next part. So this is downward direction, this is 16, this is 6, 12. So 8 minus 6 is 2, so 2 downward direction. So 2, then again in this direction 5, and upward it's your 12, that is 25, that is 6, and 12.5, that is 6.5. So here it is 5, and upside which is 6.5. Enter. Then again in this direction 15, 1, 5, enter. Then we have to create a taper of this section. So this one is 10, and upside is 25 and 30, that is 2.5. So just go to over here 2.5, 2.5, enter, and in this that is 10. So 10. So we find out this point and this point. So join these 2 points simply, enter, and delete the remaining. Either select and press delete key on keyboard, or just go to delete and delete, whatever you want. Okay, fit. Then next from here, so here it is 30. So create line, end point which is 30. Okay, and now if you draw line from this to this, it should be, sorry, this is 10, not a 30. So delete this, delete this, create line again, line, end point. This is 10 only, not a 30. 10, and again if you draw from this to this, it should be get 15. So select distance, it is should be 15. That means this line should be cut here or touches here. Okay, so our job is correct. So clear colors. Now next step, take a mirror of this, that is go to Xform, mirror, select this one, give enter. About which axis? About this axis. So this is okay, that is about, we perform about x axis. If you perform about y axis, then geometry is here. Okay, so this one is correct. So okay, now clear colors. Okay, now we perform operation on the same job. So for operation we have to select operation manager. So in this window there is no visualization of operation window, operation manager. So just press Alt O on your desktop. So Alt O. So fit the geometry. Now go to machine type, lathe, default. So again just define stock setup, stock setup. So this is properties of left spindle, that is stock. Stock is equal to make from 2 point. So select this starting, and end this starting. So 30 is the OD and 65 is the total length. Okay. Now give the margin. So suppose OD margin is 1, right margin is 1 and left margin is suppose 25. Okay. Now if you want to preview the leg boundaries, then these are the preview leg boundaries. Enter. Okay. Now define the jaws property. It should be made from 2 points. Now draw chuck. We have to draw a chuck. That chuck should be drawn between this finished job and the stock at some length. Okay. So in this way, preview leg boundaries. This is chuck. Press enter to continue. Enter. So these chuck are defined. So okay. So this is our holding job. Now the required parameter, required toolpath perform on the same job. Now go to toolpath. First we have to perform can graph. Okay, so the NC name is should be T. Okay, as it is. So start from this point and end at this point. Okay, as we discussed, the whole geometry on which the operation is performed should be converted to yellow color. Okay, then this window is open. So take any one of the tool. Suppose we take this one, setup tool, vertical. Here it is clockwise. Okay, this one is correct because our tool come from this side in this direction. So okay, then can rough parameter. So overlap amount is suppose 1, rough step 1, stock leave x1. Okay, all parameter are defined. Okay, now verify the geometry. Here should be stop on collision. Stop on collision provides means if there is a collision between stock and your tool or tool and the chuck, the tool should be stopped. That means this is incorrect program. If there is continuous motion and tool does not stop, that means your program is correct one. So just check out that it is stop on collision. Okay. So this is performed. Now next, fit top view. Now these yellow lines, green lines are shown. That is the tool path, cutting tool path. So to hide this, just press Alt T, and again to visualize this, press Alt T. It's simple. So I hide this, Alt T. The next part is facing. Okay now. So we perform roughing on this section. So we have to also remove this part also. So perform facing tool path face. Okay, so this tool is selected, setup tool, vertical clockwise. Okay, then face parameter, if you want to change, then change, otherwise leave as it is. So, okay, so finish facing is performed. So if you observe, then our finish job, select all operations, verify selected operations. Okay, this portion is also get removed. Okay, then next, top view. So we have to perform a grooving over here. So select toolpath, can groove. When we select, these three options are open. Instead of doing this, just go to toolpath, groove. Okay, so chain should be that there. Either select three lines or chain. So suppose we select chain. Okay, so starting from this and ending up to this. So so this portion is converted to yellow from green color. So, so select any one of the group. These are the group tool. So suppose we select this one. Here should be check that A distance should be greater than the depth of our grooving point. Okay, so this total distance is 6.5. So 8 is greater than 6.5. So it is okay. If it is not, then change over here. So setup tool, vertical, clockwise. Okay, then groove shape parameter, groove rough parameter, and groove finish parameter should does not change. So so this is converted. Okay, and verify selected operations, select all operations, verify. Okay, the grooving is performed. Okay, now next tool path, you have to perform threading over here. So thread, select any one of the tool thread which you require. Suppose we select this one. This should be turn off, that means it shows the tool settings have been changed. So okay, turn off only for session. Okay, select this one, setup tool, vertical, clockwise. Okay, here it is. Okay, now define the thread shape parameter, which is important part in threading. So thread shape parameter, so lead is given, which is 2. So define 2, enter. Included angle as it is, it is metric acme thread 30 degree as it is. Now measure diameter, so measure diameter is here, it is 16. Okay, now m16 means measure diameter, that is metric 16. It is not measure, it is metric 16. Enter. And minor diameter should be, it should be 16 minus 4, because here it is 2, here it is 2. So 16 minus 4, it is 12. So 12, enter. Now next we have to define the start position. So start position should be here and end position should be here. So okay, so all parameters are defined. Okay, so threading is performed. Actually threading shows this is a irregular shape, but it is not like that. So if you verify this, select all operations, backplot, go to isometric view, fit, and so this is a like this. Okay, then okay, wait, you can go to top view, and last one is drilling. So tool path, drill. So this number of drills are available. So suppose we have to perform a 12 mm diameter drill. If you want to perform 6 mm, then go to 6 mm. If you want to perform 12 mm, then go for 12 mm. So it's depend on you, because in problem it is not given. So suppose we perform 12 mm. So it should be checked that it is horizontal and counterclockwise. Only change is here. It is horizontal and counterclockwise. Okay, okay. And the next parameter we have to define in drilling is simple drill, no pick. So depth, we have to define only depth. So depth is given 15, but it is minus 15. It is minus 15, enter. So remaining points are remaining as same. Okay, so perform. So drilling is done. Okay, so diameter is somewhat larger, so just minimize that diameter, means if you want to change, then no need to again add toolpath drill. So just go to parameter, toolpath, so change the diameter from 12 to 6. So setup tool, okay, okay, simple no tool pick, okay. So here it is cross, means this operation is not generated. So to generate this, select on that operation, regenerate unlock operations. Okay, so it should be like that. Okay, now select all operations, verify the geometry in suppose isometric view, fit, stop on collision, then second is here, let group, third is okay in this way. This portion is not performed, on this portion any operation does not perform, because this is the extra length we provide. Okay, so finish. Then to generate a program, again go to G1, extension does not change. Okay, select the folder where you have to save. So suppose on desktop, in this, and suppose lathe job. Okay, this program is generated. So we have to take a file printout. Okay, close this, fit this. So this is the complete object.